Chapter 6. Locomotion is necessary for the origin and formation of the universe. The movement of stars around galactic cores, the formation of the solar system, and the continuing motion of planets and smaller bodies all involve locomotion. To understand the universe, this book therefore begins by asking us to understand motion itself. The manuscript proposes that locomotion is as old as the universe, that the first activity of existence was motion, the first stir within a primordial state. Without motion, the book argues, matter could not have formed the structures we observe. In presenting this idea, we are stating the foundational proposition from which this inquiry proceeds. Now the chapter turns to questions that lead toward insight. How does a pendulum work? Why does its period change with length, but not with the bob's mass under ordinary conditions? What is the relation between pendulum motion, free fall, and projectiles? And why do oceans have tides and waves while still water can remain calm? Simple terrestrial motions become entry points to larger questions. Every planet exhibits more than one kind of motion: rotation about its axis, and revolution around the sun. Why are planetary spins inclined differently? Why do most planets move in the same general direction while some show retrograde motion? These are questions about the causes and histories of motion. Why are the rocky terrestrial planets near the sun while the massive gaseous planets are farther away? Where did comets, asteroids, Kuiper belt bodies, and Oort cloud bodies originate? Why are some cometary orbits so elongated? The chapter does not answer these questions here. It identifies them as problems that a theory of locomotion must eventually address. Is there a relation between one star and another? Are all stars in motion? Is there a correlation between stellar mass and orbital speed within a galaxy? Why do galaxies differ so widely in size and brightness? The same central question follows us outward. What causes the observed patterns of motion? These questions may appear unrelated, but the manuscript identifies one common factor: locomotion. Motion underlies formation, arrangement, and the regularities observed in the heavens. Locomotion therefore becomes the common thread connecting pendulums, projectiles, planets, stars, and galaxies. The chapter asks further, why do planets move at their characteristic velocities around the sun? Why does the sun move within the Milky Way at its observed speed? Why does every star trace a path around its galactic core? It also asks what space and time mean when they are revealed through motion. These questions are deliberately left open so that later chapters can examine the variables of locomotion. The central proposal is that understanding locomotion and the variables that generate and regulate it is essential to understanding how the universe formed and continues to evolve. The study moves from primordial characteristics to measurable variables, and then to cosmic structures. Before discussing whether locomotion is possible in a particular system, the book asks us to recognize its proposed necessity for the existence and formation of the universe. The next section takes the argument in a different direction. If motion and matter are fundamental, can the same physical principles be studied locally and applied universally? From the necessity of locomotion, we move to the unity of matter and locomotion.